Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 28, 2026, just yesterday. It introduces a reinforcement learning framework that enables a small 1.5 billion parameter model to outperform GPT-5 on complex science tasks, hitting a success rate of about 49% compared to GPT-5's 34%. The paper is titled Spark, Strategic Policy-Aware Exploration via Dynamic Branching for Long-Horizon Agentic Learning. And as we'll see in the results later, this approach achieves these gains while using significantly less training data than previous methods. On Hugging Face, the 1.5 billion parameter Spark models are ready to download. You can try them on tasks like Science World, ALF World, and WebShop. To see how this works, Figure 1 compares standard methods with Spark. On the left, traditional reinforcement learning uses chain-like exploration. It runs multiple independent paths from start to finish, treating simple routine steps and complex decisions exactly the same, which wastes computation. In contrast, the right panel shows Spark's dynamic branching. Here, the model identifies critical states, marked with pink C circles, and splits the path into multiple branches, only at those moments. This focuses resources where they matter most, allowing the agent to explore difficult decisions thoroughly without redoing the easy parts. So, Figure 1 showed the theory, and Figure 2 now proves it works in practice with a radar chart of performance across 3 benchmarks. The chart compares Spark against baselines like supervised fine-tuning and group relative policy optimization. The dark blue line representing Spark forms the outermost ring, meaning it consistently outperforms the others. For instance, on the toughest unseen tasks like ALF World Level 2, Spark achieves over 80% success. Similarly, on Science World Level 2, it hits nearly 50%, significantly outpacing the inner lines representing competing methods. Alright, having seen the results, Figure 3 breaks down the 4-stage pipeline that achieves them. It starts on the top left with stage 1 and 2. Here, the agent begins with diverse routes, but the magic happens when it hits a difficult spot. Instead of guessing blindly, the model emits a special explore token, which triggers the autonomous branching you see in the middle panel. This expands the search only at critical moments, while routine steps continue in a single line. Moving to the right, stage 3 shows budget enforcement, where the system prunes branches that exceed resource limits to maintain efficiency. Finally, the bottom panel depicts stage 4, where these selective, tree-based trajectories are used to train and update the policy. Well, while Figure 3 illustrated the tree structure, Table 2 here quantifies the computational efficiency that structure provides. The table compares token consumption, setting the chain-based baseline, GRPO, to 100% in the first row. The second row shows Spark's relative usage, which is consistently lower because it avoids regenerating shared prefixes. The gains are most striking in the middle column for Science World, where consumption falls to just 53%. As the final row shows, this translates to a 47% reduction, proving that dynamic branching saves nearly half the compute on complex tasks. So, Table 2 showed efficiency, and now Table 1 details the raw performance numbers across 3 benchmarks. The top section lists closed-source giants like GPT-5 and Gemini 2.5 Pro. However, focusing on the middle section for the 1.5 billion parameter model reveals the real breakthrough. In the Science World L2 column, this small model achieves 49.2% success, remarkably beating the GPT-5 model from the top section, which only scores 33.6%. Finally, the bottom section confirms the 7 billion parameter version cements this dominance, consistently outperforming all baselines, including robust generalization on unseen tasks. Okay, while Table 1 focused on peak scores, Figure 4 examines sample efficiency, asking how much training data the model actually needs to learn. The charts track success rates as the training set grows from 20 to 100%. On the left, for ALF World, notice the teal line for Spark at the very first 20% tick. It starts at over 80% success, which is already higher than what the blue GRPO baseline achieves with a full dataset. This efficiency advantage repeats on the right for Science World, confirming that strategic branching extracts significantly more signal from fewer samples. Wrapping up, 2 takeaways stand out. Effective exploration in long-horizon tasks requires targeting critical decisions rather than just scaling up data blindly. By empowering agents to self-direct this branching, Spark enables small models to outperform massive proprietary systems like GPT-5 while using nearly half the compute. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.